when we had two functions like this and this, and we wanted to add them, so we wanted to get the output from here and the output from here, and we add them. What was the result? Suppose this is x here and x here. The result was the addition of the two functions f plus g, and we said this could be f plus g or multiplied by g, or f divided by g, or subtract g. So this is different, operations we did with functions, adding two functions, then that's how the result can be written at the end. Composition is something different from this. Let us see how composition looks like. In composition, suppose you have this function f here, and then you have another function before that, and this function has an input x, and the output from g is going as input to f, and then this is a final output. At the end is a composition. This is a composite functions. Composite functions. So here, the output from g is going as an input to f. This is the composition of functions, like a cascading of functions one after another. And instead of getting the output from here and output from there and add them or multiply them and divide them, actually the output from one is going as an input to the other one. So for example, if g of x is equal to 2x, for example, and f of x is equal to x squared plus 1, okay? So in this case, for example, if the input x is 1, the output g of 1 will be, what does the g do really? Just double everything. This is the input x, and the output double this x. So g just double everything. So if x is 1, 2x will be 2 here, right? 2. So the output of g will be 2 in this case. Okay, so x is 1 and y is 2. That's for the g function. Now the output of the g function becoming the input to the f function. And what does the f function does? This is the input now. The input of the f is x, then the output is x squared plus 1. So it doubles the input. You just think about the f. What does the f function do to the input anyway? It's basically the input square plus 1. It's just just square the input and then add 1. Okay? So if the input is basically here, 2, then it's going to take this 2 and square it and add 1. So 2 squared is equal 4, and then when you add 1, it becomes 5. Okay, so the output here is 5. Okay, so that's the composition of the functions f of g, and I got the result when the input x is 1. How about the general case when the input is just x? If I generally just have x here, what would be the output in this case of these composite functions? So the output here, think about it. See, this input is g, and the function just sorry, the input to the g is x, and this function is doubling the input. So just, if the input is x, the output is 2x. Okay, that's easy. So the output here is 2x. Very good. So I have 2x here. Now, this input, this is now becoming the input to the function f. So I got the output from g, which is double the x, and then this becoming the input to the function f. And what the f function does, remember, if I have any input, okay, it will be squared and then add 1. So if I have in this case 2x, okay, then this 2x will be squared. The whole thing will be squared. Okay, and then I add 1. 2x, when you square it, it becomes 4x squared. Okay, and then you add 1. So that means what? That means the output here is 4x squared plus 1. So that's what the function f does. It squares the input, which 2x squared becomes 4x squared, because each one is squared, 2 squared and the x is squared, so it becomes 4x squared, and then you add 1. That's what the function does. And the input is not x anymore to this function, f. The input becoming 2x. So that's the idea of composition of functions. So what do we call the output here? What do we call this output anyway? What do we call this output? If this is a function g and this is a function f, okay, and the input here is x, what is the output here? This is called the function of what? This is the output of f, right? This is the output of f. So the output of f here, when the input is what? The input here is x? No, the input here is not x. The input is g of x. And that's why this is a function that give you the output when the input is u of x. So that is f of g of x, because the input here to the function f is g. The input to the function f, as you can see, is coming from g. That's why this is f of g. You remember how you read this bracket or this parenthesis? Of. So that is f of g, the output when the input is g. Okay, so they didn't like the way this is written, so they said, okay, let's just make this f of g. Still read this of, right? F of g. This is becoming the new name for the output. This is f of g of x as well. So this is also a function of x. Okay, so whenever you see that, what does it mean? F of g of x, that means f of g of x. That means the output when the input to the f function is coming from g. Okay, let us see what will be the output when we change the order. What if f comes in the beginning and g come after that? Let's try that and see what will happen. Suppose f is first, which is basically f of x equal to x squared plus 1, and this function give you the output x squared plus 1, but this output will go as an input to the another function, which is g. And remember, g of x was 2x. Just double everything, every input is just double it and give it as an output. So is it going to be the same answer as before, or is it going to be different? You will notice here that if we change the order, the output here is different here. Suppose I still have x here in the beginning, but the output will not be as before. It will be something else. Let us see. Remember, here, the output is called what? The output is called g of f of x. And that means g of f of x. The same way you pronounce it, but the writing is different. This is g of f. This is the composition symbol, small circle composition, and that means g of x. G of f of x. So if this is g of f of x now, how am I going to calculate it? Step by step. So just calculate f of x first. Well, it's there. It is x squared plus 1. The input x here, the output here. This is the output right here, right? This is it. This is the output here. X squared plus 1. Okay, and we want to know what's here then. That's the question. What is the output here? So the input now becomes, obviously, x squared plus 1, because it's coming from the f. We want to know what will the g do to this input. What will this nice function here do to this input, which is x squared plus 1? Well, simply, it's going to double everything. If the input is x, we're going to double it. If it's x squared plus 1, also it will be doubled. So the output here, obviously, is a double of x squared plus 1. It's just going to multiply this by 2. So obviously, okay, I can write this here, okay, as this is double the input, which is x squared plus 1. So that means 2x squared plus 2. As you can see, this is different from the result that we got before. So changing the order and the composition bring a different result.